Alright, this is Unit 3.2 for Algebra 3, Measures of Variance, or how spread out a data set is going to be. Basically, we know how data sets can be centered, and we found descriptive statistics, the mean, median, and mode, that were measures of central tendency. And now we want to know how spread out the data set is. Here's a definition. One of the easiest ways to figure out if a data set is spread out, in other words, one data value is very far from another, is to look at the range. The range of a data set is the highest value minus the lowest. And we're going to talk about another different kind of statistic in a second, but first we're going to find the mean, x bar, and the range of the data set. So on the left-hand side here, you have 5, 5, 5, 20, 30, 35, 40. If you add all of those up, that's going to be 140. And then there are 7 values. So 140 divided by 7 is 20. That's the sample mean. Central measure. The range, how spread out the data is, would be 35. This could be anything, okay? Ages of people in a family. Maybe they have cousins that are 5 years old, or triplets, or something like that. Or height measures, anything you want. Now take a look at the graph I've drawn on the right. Imagine that there is some sort of histogram that models this data. Then the mean is 20. So suppose that I draw a line at 20. This represents where the center of all the data is. What we can do is think about the deviation from the mean. What exactly does that mean? Well, if you have a value that's at 5, and you take a look at the distance from the mean 20 to the value on this histogram 5, then this x minus x bar would be 5 minus 20, which is negative 15. So that's a way to see how far this particular value is from the mean. So it's going to be the deviation from the mean. You could do that with all of them. This deviation would be 0. 20 minus 20. This one would be 30 minus 20, which is 10. And so on. So we can get a group of data measures that tell us the deviation from the mean. So, let x be a data value, then x minus x bar is called the deviation from the mean. Already we've got 2 measures of how spread out a data set is, the range and the deviation from the mean. Suppose now that we square the deviations, add them, and divide by n minus 1. I'll explain later on why we're doing that. But in order to do so, I have a giant table of values here. It says complete the table below to find the variance of the data set, how varied the measures are. So notice that this column is x minus x bar. We already know that the mean is 20. So for this one right here, it's going to be 5 minus 20. This one down here is going to be 20 minus 20 is 0. 30 minus 20 is positive 10. 35 minus 20, positive 15, and then 40 minus 20, positive 20. Two things I want you to notice. First, if you sum all of those values, you should get 0. And the reason being, back up here, you have this distance 3 times, and then combine that with this one, and this one. That's how you get to the center. That's how you get to the mean. There's a certain number of values that are lower than the mean, and then there's a same number of equal distances above the mean. So 2 things that you want to notice. That's how you know you're doing it the right way. It should be 0. Now let's square the values. Negative 15 squared, it's going to turn positive. Zero squared, 10 squared, and so on. So now we've gotten to squaring the deviations. That just means this column right here. How about what happens when you add up this column? That's going to be sum of x minus x bar squared. And when you add all of those up, you should get 1400. This is the sum of squared deviations. You're going to understand why we're doing that in a second. But just know that we have the range, the squared deviations of the deviations from the mean, and then the squared deviations from the mean. What does that have to do with how varied the sample is? Well, it does not make sense to use the sum of the deviations from the mean because it will always be 0. So there's no way we can compare data sets because the deviations from the mean will add up to 0 no matter what. That's why we square them. So we actually have a number to look at. We're finding the variance of a sample and not the population. Okay? So the variance in a data set is going to be given by s squared. And we're going to include those squared deviations from the mean. This number. But it also doesn't make sense. So if you had, say, ages here, it wouldn't make any sense to use a number of 1400 as some sort of comparison for how spread out the data is. So what we're going to do is we're going to divide by some number of values. But in this case, because it's the sample, we're going to divide by n minus 1. And this is the variance, a very important formula. S squared stands for the variance squared. Or rather, the variance is s squared. And this is going to be how spread out a data set is, where S is going to be called the sample standard deviation. X bar is the sample mean, N is the number of values. So the variance is that whole thing, S squared. We can take it one step further. It also might not make a whole lot of sense to look at the squares. So the way we can turn something from a square back to a regular number would be to square root both sides. That brings us to the sample standard deviation, a very important parameter in statistics. The sample standard deviation is given by the square root of the variance. So S subscript X is going to be the sum of the squared deviations from the mean divided by the number of values minus 1 square rooted. From previous example, we would get the square deviation would be the square root of 1400. Now let's go back up. So it's this number divided by the number of values, 1, 2, 3, 4, 5, 6, 7, minus 1. All right, so this would turn into a square root 1400 over 6, and you get some sort of decimal answer there. Okay, so we just did the first example of finding a sample standard deviation, where S is the sample standard deviation, X bar is the sample mean, and N is the number of values. All right, there you have it. Please comment on this video in order to earn credit, and have a nice day.